Every medicinal chemist wants the same number before committing to a synthesis. How tightly will this actually bind? VM2 gives you a true binding free energy, entropy included, in minutes per ligand. Here's how to run it inside Claude Science. VM2 is VeraChem's second-generation mining minima method. Instead of scoring a single docked pose, it searches out the important energy minima of the complex, the free receptor, and the free ligand, then Boltzmann weights them into a real free energy for each. Subtract, and you get delta G bind. Because it computes entropy and anharmonic terms directly, VM2 returns true free energies, not interaction scores. And unlike FEP, it needs no shared topology, so you can swap functional groups freely. You'll need three things. 1. VM2 installed on a Linux host, a workstation, or better, a cluster, since every job runs independently. 2. Your environment set, with the VC home environment variable pointing at the package. 3. Optional but recommended, Amber tools installed for system preparation tasks. Claude Science handles the orchestration. The licensed engine itself runs on your own compute host. VM2 wants a clean raw data tree, a high-resolution protein PDB with waters and co-crystal ligands stripped out. Your ligands as ML or SD files, with correct bond orders, formal charges, stereochemistry, and protonation already assigned. A template ligand, the co-crystal pose, to locate the site. And optionally, an experimental data CSV, 10 ligands or more with empirical binding data, if you want to validate or tune. Now the setup. You describe your system to Claude Science. It loads the VM2 skill and writes the control file. You make a handful of decisions with it. The force field, GFF2 or OpenFF. The charges, VCharge or AM1, BCC, whether your ligands are pre-docked, congeneric on a scaffold, or diverse, and the mobile region around the site. Pick a queue. VM2 supports several, or will direct the run itself if you do not have a queue installed, and a core count. That is the control file. The run is 5 ordered stages. Stage 1, prep, add hydrogens, type and charge the molecules, and build the mobile shell. Run it with your Amber Tools environment active. Stage 2 pre-generates ligand conformers. Snap onto the scaffold, or place at random. Skip it if your poses are already good. Stage 3 builds the run directories. 1 per complex, 1 per ligand, 1 for the receptor. Stage 4 submits them all, 2n+1 independent jobs for n ligands. On 12 cores, roughly 20 to 30 minutes each for known good poses. All the calculations can run in parallel. Stage 5 extracts the results. Claude Science can dispatch these over SSH to your cluster and harvest the output when the queue drains. One caution the documentation is blunt about: the search is stochastic. For flexible or polar ligands, run-to-run delta G can swing several kcal per mole, even when it reports converged. So run at least 3 replicates and report the mean and standard deviation. That's VeraChem's own benchmark protocol. Results land in a summary CSV, calculated delta G per ligand, alongside experiment if you supplied it. For ranking a series, read Spearman and Kendall. For absolute accuracy, RMSE and the mean offset. And because each free energy decomposes into energy, solvation, and entropy, you can attribute what a given functional group is doing. Real lead optimization feedback, not just a score. That's a VM2 run, end-to-end, driven from Claude Science. The templates and the full control variable reference are at verachem.com. Now go find your best binders.